طبعا رتيف اليوم راح يعطينا كيس ستدي. الكيس ستدي حقته بعطيها بريف. انا السنه راحت زرته في مكتبه في جنوب افريقيا، ولما تكلمني عن البرودكت حقه ما استوعبت، يعني قلت له انه يعني احسه كلام فاضي، قاعد اتكلم عن شيء عادي جدا. بس بعد ما شرح لي كيف بدا واشتغل عليه وش الاشياء اللي طبقها عليه اقتنعت. اول ما رجعت الفندق لقيت اشياء كثيره قاعد تطبق عليه. فانا اللي انا اقصد لما قلنا اليوم نجيبك ككيس ستدي بحيث ان الناس تشوف مو لازم الشيء اللي انا اسويه شيء خيالي على اساس انه والله اقدر اصير مهندس صناعي او اندستريال ديزاينر بروفيشنال، لا، شيء يكون ابليكابل، السوق يتقبله وتقدر تشتغل فيه البزنس حقك. ف I would like to have Latif to give us a brief about his case study.
Thank you, Ibrahim. Yeah. Now, as I explained to you, I've been an industrial designer as a consultant for many years. But part of myself, I'm also an inventor, trying to solve problems that I see around me and problems that I myself experience. Not always trying to solve my customers' problems, but sometimes my own problems as well. And this case study that I'm presenting to you is a problem that I picked up out of my own need. And I'm going to take you through this. This started off as a problem inside our consulting company, but eventually ended up in a company outside our consulting company as a company that stands on its own, selling and promoting a specific product. Now, my first question to you, and you must help me with this, just a sort of an icebreaker. My question to you is, what inspired these inventions? Just sort of a general thought from your side. Say again? Sympathy. Okay, not a bad answer. You're talking to about the turtle. Yeah. No. Yeah, anybody? Simplicity. Simplicity, yeah. Creativity. Being annoyed, yeah. That's right. It basically means that somebody has a need. Either sympathy is a good good answer for the turtle, because I would imagine that the turtle didn't thought about it on its own, but somebody else thought of it for him. But the one on the left is more out of own problem. The frustration of cables falling off your desk, trying to at least improve on the need and the problems that you have around you. And this case study is very much based around this idea of a problem. And so in many cases, a problem sort of sticks with you, always thinking about it, trying to solve it. Sometimes normal people, which are not really innovative, will just see it and never notice it. I'm going to tell you about this product that I've developed, and I'm going to start off with a bit of a story of where the whole thing started. Yeah, this thing is running too quick now. Let's start with a little picture at the top. This is my little daughter. A few years ago, when I became a father, I traveled to Australia because some of my in-law family is based in Australia, and I went to show them little grandchild. But as a little girl, she was very restless in the mornings. And every morning before the others were awake, she was awake, and I had to quickly take her out of the house, not to wake the rest of the family. But during that mornings, we spotted a little pedal car in the backyard, all rusted, full of dust, never used for many years. And in the mornings, we sort of started to repair and clean this pedal car. And we had this wonderful experience every morning to go and ride on this pedal car. And when I got home to South Africa, I started searching on the internet to find a pedal car for my daughter. The only pedal cars that I could find was big heavy stuff that I had to import from America or Britain, and it would have cost me a fortune. Being a designer, I wanted to do my own thing, And I wanted to have a flat back little pedal car, something that I can sort of get that emotional experience that I had with my children during that time, and I wanted to give it to somebody else to also experience that. So I started building little prototypes of wooden pedal cars made out of flat sheets of wooden ply that were basically in a state that you can home assemble it to, as a parent or a grandparent, build it with your child. And through the normal design process of a prototype, as I call it, the proof of concept, because you need to get to a proof of concept before you can spend more time and further develop it. I went on to a CAD drawing where I had all my parts, my wheels could turn, I could get the steering to work, got into a technical drawing, went into a CNC manufacturing of the board, and eventually I had a finished product. And that product I took to market. That wasn't my thought at the beginning, it was more a thought of sort of a self-need. But it eventually was a product, and also an international product. We had very good response from Europe. And at that point, I knew more problems than I knew at the beginning. And that was Dr. Mohammed's question of where do you draw the line? Where do you start to put a product into market? That was my first point. And from there, I actually realized a bigger problem that eventually became a bigger company, a bigger product. But this was the start of my second product. And the second product is Edgitech. Now the problem that I had was, how do I join plywood, in the case of my little pedal car, or plastic sheets, or glass sheets, or wooden sheets, or composite sheets that are thin together. Now typically if I just take these two books, they are each, say, about 9 millimeters thick. They're made out of paper, but imagine this would have been two pieces of wood or plastic that you had to join together. The inside might not be very solid, so it might be partly hollow, like a chipboard or a partitioning board. So you need to now sort of get these two parts together. Now, I don't know if you guys have ever had similar problems, and if I would like to sort of know if you have got any suggestions before we sort of get to the answer, to see if you at the same sort of starting point where I started. Anybody suggesting how we would actually join pieces of plastic to pieces of wood that's very thin, or pieces of glass to aluminium sheet?
في أحد عنده اقتراح؟ فاهمين وشلون هو يبغى يربط القطع البلاستيك مع قطع الخشب؟ اي وشلون يربطها؟
Yeah, right angle.
Yeah, right. نبغى نثبت
yeah. Okay, but yeah, let's there's a key section or a joint.
Section or joint interface between the two.
Somebody else mentioned glue that I picked up. Glue. Yeah, glue.
Magnetic.
Epoxy glue, yeah.
Magnet. Okay. what's يلا.
Two sides, yes.
حلو الطاولة الأولى هنا عندكم شوف في إجابة. قاعد يفكر.
By a bolt or a screw, yeah. Yeah, but it's possible. Yeah. Very thin stuff. It's going to be quite difficult. Yeah, but even a screw might work on 6mm, but it might be quite difficult to heat it right. So yeah, no, okay, it is perfect. Yeah. Heating plastic or welding it, yes, yeah. Yeah. No, it's not always possible. Epoxy glue what might work also. Okay, but great. You guys were sort of on the right track.
يلا نبي ابداعات.
Yeah. And big interface between the other.
Okay. Yeah, a joint. Yeah. Okay. Let me sort of. Okay. I'm not going to get it.
ما فهمنا. would like دكتور محمد نبي عبد الكريم يشرح لنا الفكره حقته. انا ما فهمتها. هو قاعد يرسمها الحين. ايوه.
ثاني راح اشرحها اقول. ممكن يصير البارت واحد من البارتات يكون فيها بالشكل هذا اجزاء، يكون فيه هولز بنفس الثيكنس حق البارت الاول، والثاني يصير يدخل في هالجزء. ايه يصير تداخل بين هذه الفكره، هذه الوحيده ترى الوحيده. You know.
Yes, I understand exactly what you're saying.
I think that.
Yeah. Yeah.
هي الفكرة الوحيدة ترى. هي الفكرة الوحيدة الموجودة. الفكرة الوحيدة. لا هو فكرته هنا يستخدم. لا هو فكرته قبل شوي هو بيستخدمها عشان تركيب سهلة التركيب تمام. بطريقة غير
Ibrahim, there is somebody for the mic.
نفس حاجة الباب.
A hinge.
ها؟
Yeah. It's
زي السبورت يعني.
Great. I must say I'm impressed. There's a lot of options. The idea is not to sort of get to the answer that I've got, but just to get you thinking about all the possibilities that there is. Because many possibilities is a possibility, but it might not be a possibility in production. It might not be a possibility for home assembly. It might not be a cost-effective way to do it. So there's a lot of criteria that you have to get all these possible solutions and look at it and study that and see which one might work at that point and which one not.
معلش دكتور، في الايبوكسي جلو في شيء متخصص في لحم المواد المختلفة، يعني قزاز مع بلاستيك مع ربر مع خشب، هذا في انواع متخصصة. كل واحد يقدر يسوي كيف كل واحد يقدر يسبلاي الجلو. يعني it depends on the material. وهذا فكرة انك تسوي منتج اي مفتك مظبوط لما تخليه شيت. اي معناها البوكس حق الفوليوم حق على يكون فلات. اي ويكون شيت از ماني از يو لايك. والمانيفاكتشرنج حقته ماس برودكشن سهل. هذا التجميل عرفت الفكرة ليش؟ انه اصلا بدا بالماتيريال هذه. الان تثبيتها وتركيبها ودي باي واحد في البيت مجرد اوكي. هي جاتني انا فكره، بس هو I think we can make T-shape hole، يعني يكون في مجرى في مثلا الخشب والبلاستيك يدخل فيه وخلاص يصير ثابت. لا يعني يكون في زي المجرى.
No, I like it. It took me a while. But I'm going to complicate it a little bit more now.
بس اللي انتم لاحظتوا كل واحد بيجيب فكره، بس انه اذا لقيت حل واحد فيك تستغني ما تبغى تشوف غير الاخرى. وهذا خطا. الخطا انك انت تشوف قطع او تشوف قطع منتجات كذا، انت كانسان تبغى تصير مصمم لما تشوفه تبيك لعبه ولا تبيك حاجه شوف الحلول الاخرى. ليش لا تسوي كذا؟ خليك ناقد شوي. اذا صرت ناقد معناها انك تكبر اذا لقيت غلط خلاص فكر بالمزامين. لا فكر هل هذا اجزاء اجزاء. هذه من الفكره المقصوديه. الان كنت كم واحد لان قلنا لكم ما حليتوها كل واحد قام يجيب افكار اخر او طريقه اخرى. هذا المفروض نكون مع بعض هو الحمد لله حليتها احط محلك. بعد هذا انسوها ذي.
Let me quickly just go back to where I started. I had a product that was made out of flat sheets. The dark brown products had a section that protruded through the side, allowing it to register and stay at that position. Then between my side paddles, I had tension devices that were actually pulling these flat parts onto the black or the dark parts. So there was a definite pulling action that I needed, and there was registration that I need from the parts in between. So your idea about the grooves, it basically relates to this. But the major thing is I couldn't use glue, because this part needs to be disassembled flat back, get to the end user, he needs to assemble it, and once his child is too old to use it, he has to put it back into the box for the next generation, because it's a quality product that needs to last for more than one generation. That was the criteria that I had for myself for that. If we look at the screws and nails options, so we've sort of looked at the options about sheet material. So, okay, we've actually been this one. So how would you do it? Let me just get to the next one. Sorry for that. So we've sort of touched on known principles. The glue method, a hammer and a nail, a screw option, your jointing option with either glued or not glued, trying to keep your parts together. A second suggestion, and this gentleman here mentioned clips. You've all been to IKEA buying flat pack furniture. When you get home, there's all your wooden parts and there's a little plastic bag with all these funny things in it. Now that's systems which are not sort of a DIY solution, which is more a mass production type of joining system or a mechanical system to align and fix flat panels. But I couldn't use these. And the main reason for that was my boards were too thin. I wanted to make a pedal car from 6mm sheet material, and most of these fittings, you had to have a material which is minimal 16mm before you can apply it. Although I've learned a lot from these things in the way that they solve problems on their advantages and also on their disadvantages, there was another aspect that I had to take in mind. And that was the tools I had to actually apply my fitting or my solution onto the actual material that we used. Just to explain you quickly, there's two methods that normal furniture in mass production are made. First one is with CNC, which is mainly a two-dimensional profile cutter, allowing you to nest a lot of components on a sheet. And once it's been cut through, holes, profiles, whatever are finished, and that component gets off that machine. The second option, and I'm only showing you the one machine which is used in the inline manufacturing, and this is where Kia works. They've got a bandsaw or slitting saw that cuts all the wood into square parts. These square parts go to an edge bander and eventually ends up in a multiple drilling machine. Why I'm calling it 3D, and you'll see when I get back to that fittings that we've just referred to, they're all multiple direction fittings, meaning you've got a hole from this side, you've got a hole from that side, and somebody can't do it at home. That's why it's not sold into DIY. You have to do it in a manufacturing process to get all the alignment accurate. I didn't have that luxury of accurate three-dimensional drilling. I've only had a profile cutter, a CNC machine that can only take one cutter at a time. So I didn't even have the luxury of changing cutters and doing funny things. So that was my three areas that I had to solve. So then we sort of started with the design phase. And this design phase actually didn't take that long to get to the initial idea. And the initial idea was to try and get a fitting which is in line with the sort of mass production knockdown furniture fittings, but something that worked not only from one side but from the opposite sides, allowing you to actually get hold of that thin panel. In that sense, extending your footprint or your base on the sort of the opposite side, trying to get that as big as possible to stabilize it, trying to use your bolt to anchor your two parts. So there's a couple of things that we sort of worked through when we developed some of the ideas. We don't have a growing machine in our own company, so we send files out to a 3D printer. Now, unfortunately, if you don't have a machine, it costs you money. So we use a method called silicone molds to reproduce that little part, which is much cheaper than to actually print 100, because we wanted to test it, the fitting on a car, on other applications. So through the design process, we tested every time that we had an idea to see if it actually gets to that tick box of actually pulling enough, registrating the panel to the next panel. Is it user friendly? Is it reusable? Can you screw in and out 50 times before it fails? And then we got to a fitting. I'll just call it the breakthrough solution. It was a two-part fitting that clamped from opposite ends onto our panel. Just to explain to you, there's my flat part. It goes through a CNC process, which is actually cutting the outside of the part at the same time that it cuts two key slots, which is off the edge of the sheet. Still two-dimensional, no multiple drilling. From there, I've got the two parts of the fitting, and I'll show you the examples now. A male and a female that basically enters from any side that you wish, but they make a set. Inside that set, there's a little loose metric nut, which we use to basically as a female side to the male bolt that will enter into that. And the two-part clips onto the panel, which was quite a nice state for us to have a component. So let's think about it. IKEA sells flat-pack furniture. They don't sell finished components. They expect you to finish the component, put the fittings in, get home and trying to figure out how to actually assemble the component before you can make a product or a desk. Advantage about our fitting is that it would actually go out as a finished component, that the end user never sits with a bag of fittings and a pocket. So that was one of our interesting sort of advantages that we only realized quite a lot later, which distinguished this from normal fittings. From there on, you can now sort of screw your 90-degree corner onto that part in that state. The next stage for us, from a sort of a marketing and company perspective, we needed to test this thing to see how well it actually performs. So we took our competitors' products, and I couldn't really list their names, but they've got key sort of codes in our company, and we did some very basic tests, pulling straight off on a T-joint, getting a deflection test for a part actually deflecting, getting side pressure. This just shows you, this is a result of a deflection test, so the less deflection, the better. It shows you the standard type of cam and dowel type of fittings, how well we performed even on our thin panels and our fitting. Our ones was the one marked in red. And we had two configurations. We had two models at that stage. We were still evaluating which one of the two were the best. So that's why there's a two code. A W stands for a fitting with a wing on it, and the S standard for a fitting that had a simple shape on it. Just to, because at that stage we weren't sure exactly which one would be the best. From here, in a normal product, you never design and develop a product in isolation. So we had two potential customers. One closest to us were the manufacturer, and the eventual customer or the end user was the guy that had to assemble his product at home. And there were a couple of criteria that we had to keep in mind during the development. Price, the fact that it needed to be strong, a little bit of an anti-screw, a cost-effective, simple alignment. And we sort of developed this idea, trying to explain to people that it's quite simple. Although it's new technology, people are always hesitant to buy into technology, and you have to, in a sense, keep things simple. And we developed this idea of, we call it the 3 easy steps: a cut, click, and a connect. Just from a sort of a marketing idea to try and to overcome the fact that it's new. Because in many cases that is a big barrier to entry for possible users at the end, is that they have to now change their technology from something that they've been working with for many years, and now you come with a new idea. Although they think it's novel and very, very effective, people are always hesitant to change. So we had 2 basic fittings. We had a T, and then we've developed a little corner adaptation onto the fitting, onto a side panel that allowed you to do a corner. And this was our starting block. And that's the fitting that we first put to market. We did a 6mm and a 9mm. And quickly we realized that there was interesting other requests from our customers. Somebody wanted to have a hinge. Somebody wanted to have a character on the fitting, because now I can do children's furniture. He had the Disney license and he wanted to see what we can do. So we pitched a lot of ideas to different customers, and suddenly our business grew from just being a single fitting to a whole family of products related to only that specific part. We went up to 16mm, which we thought we will never do because we are competing against 16mm, but suddenly people liked our fitting at the thin panels, and we soon sort of graded up to selling 16mm fittings. And this is how Edgy became a business. Edgy started off with a simple principle of an edge-mounted fitting onto a thin panel. We soon realized, but we've got quite an application on board materials. We thought we were only on wood, but suddenly we had customers with glass, plastic, even hollow core material. Everything that came in a flat format were potentially our customer. So on the board size, we knew that there's options for us. On the back side of Edgy, we soon realized, but as soon as we've got an edge-mounted fitting on the edge of a board, we have an interface to add on. And that's where we started to, I'm just going to show you this, create little hinges. That was the hinge that we can have a look later on it. Put a little hinge on it, a T-section, a corner, an inline hinge, little feet, little hanging lugs for signs in shops, pole extensions for round poles to get the fitting onto a pole. Even a 3-cornered fitting for the packaging industry was one of the solutions that developed from there. When you're developing new ideas, you always need to think on how can you protect it. Fortunately, in our case, it was a new product and there was strong IP in the sense that we could register a patent. And through our design development, from the first one to some of our second adaptations, we've been able to register patents in quite a few countries around the world. Patents are expensive, and it's not a once-off payment, it's a process that you take through. Our budget for a single patent is between 800 and 1,000 South African rand. 800 to 1 million South African rand, which is... Yeah, but that's if none of your patents are contested. We were contested in the United States, that actually almost tripled the cost. for that country. So it's yeah, it sounds about right, because it's $150,000 is about a million, 1.1 million in our currency, which is about what we also pay for them. But that's over a period of about 4 or 5 years that you would need that sort of, yeah. Yeah, but there's quite a no. Yeah, yeah. Yeah, to pay it out of your cash flow. Yes, you always you reserve the right to protect. So you always have first priority or first right to protect if you're in the process. Yeah. Yeah. Mm. The next aspect is let's look a little bit towards the marketing. Yeah. Oh, some of this are very light. Okay, this is potential markets for us: furniture, signage, retail point of sale. This one is interior and industrial. We've got shop fitting, outdoor applications, and that one there is exhibition stands. So we've sort of tried to map our potential market. From this side, we looked at what would be, what is a big market, where is there big potential, and which of these potential is the easiest to get into. Next question that we ask is, what of these segments are the early adopters? Because we're selling something new, we want a market sector that can adopt and that can actually buy from us before they or early. This is some of the pictures that we've got. So we've got a little bit in the furniture, the toy side. We started in the point of sale. We did it. That's also a little bit in the furniture side. This is more towards industrial design side. Then we also sort of had to see who would be potential customers and try and focus on specific market leaders. Because in every segment, there's specific influential customers that you want to target and get as your first customers. So typically, this is South African companies that we spotted in one specific segment, which is a segment of the point of sale or the retail ones. And why we picked that one? Because they were the early adopters. And inside this company or this segment, we picked on specific companies like agencies, manufacturers, board suppliers, big point of sale manufacturers, guys that are more into the packaging that fits onto point of sale. So we've tried to at least cover crucial and very selective customers in that segment. Now I'm going to just show you some.
All of them are wholesale for you.
No. We still sell directly to the end customer. And why we've decided to do that for our first 2 years of business is because that's the best way to understand your customer. If you sell through a wholesaler from the beginning, you're never going to know what went wrong and what is right, what your customer wants or doesn't like from your product. So it's for us, it's important to keep the line to the customer as short as possible in the first 2 years. But in our pricing at the beginning, build enough meat or raise the price enough so that in 2 years' time we can sort of flow over to a distribution system without raising the price to our customer. So you need to sort of plan your route to market, your strategy around that. But eventually the distribution is where we need to go. I'm just going to sort of, to end off, show you some of the products. And these products are mainly designed by Edgy itself. Now, Edgy sells fittings, but you cannot sell something if you can't prove it in a product. So a lot of these products are what we call showcase products. Although we sell some of them, it's not money makers for us. It's a way of building our image so that people can relate and understand where and how to use the fitting. So even in our own office, we design our own furniture with our fittings, because if people come in there, they need to see that there's people that's got confidence in their own stuff, they believe in it, and this is how it's potentially being used. Just a few examples of storage systems where Edgy gets used. All thin panels, just a matter of interest. The fitting comes from two sides. It also allows you now to sandwich different thin panels together. So 2-3 mils gives you a 6 mil. It works on a 6 mil fitting. Children toys is because I started off with a little car. We've got an emotional connection to children's toys, so quite a couple of our showcase products still relates back to where the fitting started, being toys. But I think from Edgy side, we pride ourselves in the fact that our toys and our products are well performing, well finished, high quality stuff, because that's the type of image that we want to project as a company. Just some of the other fun things. South Africa had the World Cup soccer 2 years ago, last year, and we did some fun projects just relating to our soccer. Some of the more functional products that we did, little furniture for children as well. All flat pack, home assemble. Also for little daughters. If you're a father of a girl, you need to also do something for your daughter. And then this is the sort of the market, which is our biggest consumer of our fittings, is retail point of sale. And I think the advantage that we bring to people that actually produce point of sale is that previously point of sale was mainly glued together or nailed together, and it couldn't be shipped to the store and erected in store. So we save our customers a lot on transport. But I think the other main advantage is that we have found a niche in that specific market where the cost of the stand and the actual structural ability of the stand comes together at a point where we present the best value for money in that specific area. Now in South Africa, beverages are big and beverages are heavy. And beverages have got big budgets and they do lots of promotions, and it's very ideal for us. We build stand and design stands around beverages, and it's a big part of our business. This is not a beverage stand. This is more a fast food type of stand. All these stands, just for matter of interest, goes into the fast consumer goods, the big retail stores where there aren't salespeople to help you to choose products. So they use promotional stands to sell and push products to their customers. They're all branded, so it's very much a branded exercise for a company as well. Basically, to get back to the end where we started with our little car, this was the outcome of the whole exercise. Now we have flat panels with our fittings on it, finished as a component, so that the customer eventually can screw in from the side, and the fitting serves the purpose of registering the parts, pulling my side panels in, all still on our flat panels. Yeah, that's the end.
Thank you. Okay. أي سؤال يا إخوان؟
Yeah, just for the last one, I've got some samples of our fittings.
We can show it around.
I think we didn't expect so many people, but please help
They
us.
can take it with them? Okay.
The board that you see on that fitting is just the example of.
Thank you very much, Rizzi. The next question, how do we improve this design further? Huh?
Please, I would love that.
We will charge him before he leaves. شباب، هل في أفكار تطويرية لهذا المنتج؟ وش أكبر مشكلة؟ Yes.
Maybe we can just make this joint a little bit smaller by using another material.
Good question.
شباب خليكم معنا، هذه ترى بدأت الانترستنج الحين، طلع لنا شيء ما ندري وشو. الآن نبغى، هل في الأفكار هاي جديدة تماما؟ هل ممكن نطور المنتج هذا؟ فالمهندس محمد الشمري، مهندس كهربائي، لا تاخذونه. بدأ الحج. زين. اقترح التالي، تفضل.
How about to reduce the size of this joint by using other materials?
Okay, before I answer it, can I ask you another question? Why would you want to make it smaller?
Now you know that he's electrical engineer.
Is the question because of the visibility?
Maybe we can reduce the cost of the material itself.
Used, okay.
Okay.
And we can ship more parts in a small area.
Also the flatness of the surface.
Okay. It's an interesting question. I think the time that we started designing the fitting, the size was not really one of our key sort of decision factors. So the size of the fitting was more a perceived size at the beginning. There is still a mechanical function towards the fitting that once you sort of scale it down, you lose some of your strength properties. Because if I size that fitting up, I will definitely have a stronger joint. So that would be one of the answers.
You need a certain area to pressure on the panel in order to hold it.
There's another aspect. From the manufacturing side, you cut that slot, which the smallest size is at the moment a 12 millimeter gap. If you reduce that fitting, you need to cut with a smaller cutter. And on a profile cutter, it's going to increase the cost of the actual cutting of your panel quite a lot. The choice of material, plastic versus something else, I'm not sure exactly what one would pick in a different format.
Plastic itself, it has many different grades, you know.
Yeah.
Some are the most strong.
We've tested the plastic. We've molded through our mold a variety of plastics. We've shaped our shape according to the shrink ratio of each of those plastic configuration, because one plastic shrinks a little bit more and one less. So we've jigged up for all the shrink ratios of it, and we took them all through exactly the same test. We went and spoke to a doctor's degree mechanical engineer that did the report for us.
شباب شغلي. They went to Shigli. You know, the design course to improve to test
all the different types of plastics. This thing is dying on me.
Okay.
But and then he sort of suggested, because our criteria was strength, impact, and long stability. And through those three criteria, we've tested all our fittings by impact, by duration, and we came up with a plastic that was the one that equaled all three of those, which were, fortunately for us, a plastic that molded very easily, and which was normal ABS. And it was cheap for us, because we started off with acetyl, and all funny plastics were very expensive, very strong, and we realized soon that through that study, we don't need it. We can stick to normal ABS, it's sufficient.
سابق thanks you for that.
Say again?
سابق thanks you for that.
فهمت
شيء شباب ترى this is very interesting. ترى فيها ذهب.
Yeah, so
وكالة ولا
the
شيء.
principle is scalable. The question is it really needed to scale down or up? And is it cost effective from a production point of view and from a material point of view to change it?
Okay. إني أنا okay. تفضل.
بالعربي والبالانجليزي. If we can fix this one, so when the screw goes in, it do not hit the material, this material. So it's like if this is a glass, for example,
Yeah.
and the screw is going in, then he's going to make it to crash. Or
The length of your screw is determined by the thickness of the panel that you screw towards it. So you need to get the screw to end onto that face before it hits the rear end. We've designed that profile, although if I can open that one up. You'll see that that's our standard profile, quite a simple one. But we've adapted that profile to have an extra little niche in here for glass, to prevent people from using the longer screws, because it's a problem that we've experienced exactly in glass, because then it shatters the glass. Yeah.
and it depends always also on the other material that's going to be.
Yeah, our secondary part.
Yes.
On that side, we use a little dome, plastic dome, to spread the load, so the screw are not concentrated on that specific place where you bolt it.
For this product, how much kilogram does it handle? Yeah, wait.
Yeah, let me explain to you on this one. We haven't done this on that material, but on this specific, it's a 6mm acrylic. You can pull 100 kilograms off the edge. So I can hang on this. Just. The deflection.
شوف حتى كذا ما ينفك بسرعة.
The fitting is not always the strongest element in a shelf. So you need to you compare apples to apples.
شلون؟ التصميم حقه.
There's the hinge, that's the extension, so that's the standard fitting.
هذا بنسوي في الجروب.
You can pull it.
طيب ما هي improvement؟ I have problem with I don't want to use it. I'm not sure to use it. This is the most time consuming.
Let me show you this. No. I'm going to take you to our concept stage.
أنا ما أبغى سكرو، شو السكرو؟ أعطونا أفكار. لاحظوا الكليبس ما راجع. ودي جالبة.
This is a different fitting that we've designed, which was not because in that fitting we've got a male and female part with a nut. This is a single fitting. The same part comes from both ends, and once it's in place, we've got a plastic screw that you hit in from the side and it locks it.
But then you cannot take it.
No, you cannot take it.
I want it to be taken out.
Okay. It's a challenge. Come, you must solve this.
نستخدم زي شفت اللي زي شفت اللابتوب الان فين كيف زي كليب ولا هذه مثلا تطلع ولا هدف كبير اوكي كليب بس بعدين تطلع يطلع او you want to use you get up the all idea the clips you know the internet connector
Ethernet cable. Ethernet, yeah. With a little clip on the side, yeah.
So you just put it inside and still there if you wanted to take it out.
But you won't have access to that side.
Huh?
You might not have access to that point.
But how do you screw this?
From the outside?
Yeah, you want the screw to be like this.
Okay.
Yes.
Yeah.
Like
Okay.
something like
Yeah. The main part is that you still need pulling in one direction, so it might need to be a ratchet because you might have different point where it clicks in, not only a single point, because you want to create pressure. A normal RJ45 has just got one point, there it's in and out.
يعطيك لود على كل الجسم حق الفوق. هذا يسميه الويت او الجسم على نقطة واحدة. ممكن تكليف لا تلقى بالصورة هذه. يجي واحد بالغلط يفتحها خلاص. بس هي حلوة الفكرة هذه. يمكن المفروض دايركشن فوق.
Yeah, I think it's a good idea. I think so. Yeah. It's possible. I think one of the features of our fitting is that you can actually pull a panel into the fitting. A normal cam and dowel only holds and releases, but our one had a pulling action, so you can curve sides of the car. My little pedal car, the sides are flat, and then you pull it into it. So the length of your screw allows you to pull apart into the fitting, which the normal fittings don't really have. So in a sense you're going to lose that, but there's an advantage about the clip action, which I think is also quite a feasible option.
Combine it. Go to the old all the time.
This one. Even further back to the car.
Old not IKEA. Yes, IKEA. So maybe we can do something like IKEA, just one turn.
This is a one-turn screw, the cam and dowel.
Yeah, but in your fitting, in your plan,
Yeah.
like
Yes.
one.
Yeah. What in our patent? In our patent, we also you see, a patent is not a inclusive an answer. It's an open-ended agreement in a sense. So in our patent, we've pitched a few solutions which are covered in the same patent. So you can use a nut, but what we've done is we've designed a nut that can tilt, and the slot is oval, and we've got a coarse thread, so you can push it in up to a point where you turn it and the nut flips back and it locks. Yeah. So that was one of the features that we built into. Unfortunately not. But you can buy mine. You can buy mine. Yeah, no, that's the right way to look at it. But our problem at the moment, before we commercialize it, is the manufacturing of that specific part is too costly at the moment. And yeah, so there's a bit of development around the manufacturing of that idea that needs to still take place. There's a sample of a hinge somewhere. You must all have a look at it. It's basically an addition onto a fitting, that one there, that allows you to basically hinge on panels.
لما الأفكار تبدأ من أي شخص، تجي من محاكاة شيء، من وحي، من أنا أقول لك يعني تجي الفكرة من أي شخص في المجتمع. دورك انت كاندستريال انجينير ولا اندستريال ديزاينر ولا ميكانيكال ديزاينر ولا انجينير ان جنرال، انك يو بيك ذس اب وتحولها الى عمليه تطويريه، ثم بعد التطوير الى عمليه قابله للتصنيع. هذا اللي ودنا نتخرج منه. انك تصمم بنفسك وانك تسوي اناليسيس بنفسك ترى مو بهالضروره. التولز موجوده وتعلمها، تاخذ بعض التولز اللي يعني تتعلمها اسبوع اسبوعين، تاخذ سيرتيفيكت عليها وخلاص. يعني هن ما ندرس الشباب، انا برجع احش انت، ندرس الشباب كما كانوا هم اللي بيطورون السوفت وير اللي بيستخدم، زي ما ندرس الرياضيات ندرسهم لدرجه هم اللي بيخترعون النظريه الجديده. بينما لو ندرسهم اللي بيستخدمونه ونركز على الفهم العام كان مهارات اعلى، والعوده الى المانوالز وعوده الى شو اسمه للحلول الموجوده سهله على الشخص. يعني الان انا يمكن المهندس عبد الكريم المطيري في البرنامج اتوقع الان يقدر يتكلم عن تجربتين: تجربه التعلم من خلال العمل اللي هي مرتبطه، انت تحتاج لشغله تروح تبحث عنها وتجيبها، او انك تدرس مع شخص او تعمل مع شخص يكون متقدم في الشغله. فانا عمليه التحول من اندستريال ولا الكتريكال وكذا انك تصير انوفيتيف، مساله هاو تو كابتشر الايديا ممكن بسكتش، بعدين تكون معك زميل اخر عنده معرفه فكريه ويحولها الى انجينيرنج دروينج، وبعدها شخص اخر يطبعها لك على 3 دي، اصبح عندك شيء ملموس اللي هو تعب هذا الرجل عشان يسويه. في ورشتنا نسويه خلال اسبوع. يعني الفيتنجز هذه وي كان برنتد لو بغينا ونجرب. لو كنت واحد يبغى يشتغل شغله لو هو موجود عندنا، I'm talking about you saying that if you were working here at Baader when you did this you would have everything available for you in a week time. You will do it because you can just print and test immediately the plastic fittings, and we have a laser cutting machine and we have CNC machine, so you can do prototyping quickly. الفكرة اللي أنا ودي تخرجون بها أنكم تشتغلون كجماعة، ما يحتاج كلنا نعرف كل شيء. فلما نشتغل كتيم وكذا، أول شيء شير الأفكار حقتك. كثير من الناس يحس من فكرته، عرفت يعني، زالنا واحد يقول أنا بكون نوبل برايز وينر، عرفت يعني. هذا الطموح زين، بس إنه خلي الناس شوي بعيدين عن الواقع. ولا أنا واحد كاتب خطاب لنا كاتب المخترع فلان فلاني، ما أدري وين الشهادة تعطى هذه مخترع، عرفت يعني. فيه دكتور عارف انه ياخذ دكتوراه، والمهندس نعرف انه ياخذ هندسه، والطبيب يصير طبيب، بس مخترع ما ندري وين ياخذها، ومسجل باتنت هذا شيء ثاني. لكن هذا اللي نبغى صحه شباب. بيجونا ناس بافكار حلوه كثيره بس ما عندهم التعليم. انا جايني واحد في ذا وقال انت مجنون، قال لي يشغل وينه ابراهيم يشغل كهرباء كذا. ايش قال؟
ياخذ الكهرباء يحطها في البطاريه واذا بغاها يسحب البير المويه.
لا هذا واحد ثاني عندي على الكيفات، هذاك طفى الكهرباء عليها ويقول الكيفات شغاله بسبب بكرات. ها اي، فانا قاعد اشرح له وكذا، والطاقه لا تفنى ولا تستحدث من العدم ومدري ايش اللي كنا ندرسه متوسط، عرفت. فقال لا انت ما عندك سالفه. فقلت له ترى في شيء، في اختبارات نسويها هنا عشان نعرف واحد عاقل ولا مجنون. يعني مسخها معي فجزء من هذا يا شباب، يمكن للاسف تجدون دكاتره وتلقون مهندسين وتلقون ناس متعلمين تعليم جاء وتجي تقول لما كلام غير منطقي ويقبله. فجزء من التوعيه هذه اننا نقول تعال يا حبيبي، هذا في مواد، في علم، في كذا، عرفت، علمني وش المنطق اللي تبيني تعشي. في واحد ما يعرف علم الحركه وقاعد يسوي لي بكرات، ولا مثلا واحد ما يعرف الطاقه وشي، سوى لنا بيحفر في بير، يشبك الجهاز حقه البطاريه ويعبي بطاريه سياره تنشحن بعير، تحرك بعير، ثم يشغل بها مروحه. زين، ثم يقول شوف ما قضت ابد البطاريه. زين، ثم خلاص يقول انا ما عاد احتاج ابدا طاقه الرياح، المروحه اصلا تشتغل على البطاريه. فانا والله ما ودي نضحك على هالاخوان هذول، لكن ترى جزء منها الجهل. جاي واحد قال انا مخترع نظريه افضل من فيثاغورس. ايه قال الوتر يساوي جذر 2 الضلع. هذه مختصرة فعلا، ولا جذر مدري ايش وتربيع وتتعب، ما تحتاج هذا كله. فقلنا له قلنا والله يحتاج يرجع ثاني متوسط يدرس، الظاهر ما مرت عليه ثاني متوسط، هذه حالة استثنائية من حالات قانون فيثاغورس لما يتساوى الضلعين. كثير أمثلة. والسبب انه وش نتكلم؟ لما طبعا كلكم ممكن بعضكم على تويتر يتكلموا كذا، وش تتكلموا فيه؟ تتكلموا في السياسة، تتكلموا في الدين، تتكلموا في ما تركتوا الأهم من هذا كله. تتكلموا في علم يفيدك ويفيد غيرك، اللي يميزك، الانبوت حقك وين يجي من؟ لا تتكلم في أي على قولهم في شيء كل يقدر يتكلم فيه. تكلموا في الشيء اللي تعلمتوه وجربوه واغلط وحاول واغلط وحاول واغلط، لكن خليك في الاتجاه الصحيح. والشراكة مع الزملاء، الحل واجب مع بعض زين، لكن مو إنه واحد يحل وعشرة ينسخون. ها؟ كوبي بيست والقويفل شغال. زين، انتبهوا من هذه النقطة، لكن أنت اللي في الأخير عرفت. فترى هذه أنا إن ماخذينها من جانب الديزاين وكذا، لكن الحقيقة هي اللي قاعد يصير هذا، والتجربة هذه اللي نخوضها ما ندري شو نتائجها إن شاء الله، لكن ما في شك إنكم إن شاء الله طلعتوا قبل 3 ساعات، الآن عقب 2 أو 3 ساعات من الجلوس المفروض إنكم طلعتوا بشيء زين. يعني على الأقل تعرفون إنه ممكن واحد يراجع أن العملية التعليمية اللي يشوفها هذه لا تعني أن هذه هندسة، ولا بتعني هذه الطريقة المثلى للدراسة، ولا الطريقة المثلى إني أنا أصنع الكارير حقي. لا يعني ما أدري، الواحد ما يرضى لنفسه إنه يكون 5 سنوات. هي أحلى عمرك هذا اللي أنت تعيشه، أحلى أيام عمركم هذه، وهي اللي تتشكون وضايقون المصعد البستم يقعد 2 ساعتين عشان يلقى الدور الثاني. تضيع من عمرك واجد. خذك
بس على اساس بالختام، بس اللي احنا في الجروب حق الفيسبوك نبغى ودنا نفعله. يعني عبد الله عمر ما قصر معنا في موضوع الجروب، وكثير من الشباب اضافوا فيه. هو الهدف منه عشان التواصل اسهل منه. وغير كذا راح نبدا في مساله اللي هو الكارد اللي يتكلم عنها الدكتور، بحيث انه يكون في اكسس، راح يكون في الاونلاين تريننج، راح يكون في ملتقى هنا بشكل تقريبا 2 او كل شهر على حسب المتوفر. راح يكون في نشاطات معينه خاصه في الديزاين، مو بس في التصميم نفسه، في اشياء ثانيه متعلقه له كالبزنس. فهد المهندس فهد كان بيساعدنا في اشياء معينه من ناحيه البزنس، ما شاء الله خبره في المجال هذا. فان شاء الله بنقدر نفيدكم ونستفيد احنا منكم بعد، لان كثير انا تو في تويتر جاني واحد قال في عندكم ناس يشتغلون بارت تايم، انا مستعد ارسل لي قائمه الحضور اللي متميزين يبي نشتغل معهم تو قبل شوي او ما بدينا. هذا شيء مبشر يعني كويس، فالواحد يطور مهاراته على اساس انه يقدر يوصل شيء في السوق، يقدر يتواصل معهم فيه. الله يعطيكم العافيه، ما قصرتوا، شكرا لكم.